Let's go over this trigonometry question. If you're installing a 3-foot solar panel so that the panel tilts upward at a 31.8 degree angle from the ground to ensure optimal sun exposure. Let's just pause right there. If we didn't have this picture already, we would want to draw a triangle, a right degree triangle. It doesn't matter whether this is right facing or left facing, so we could draw it out the other direction, but we would want to put the 31.8 degree with the, assuming the ground is the horizontal, and then we would also want to label the hypotenuse as 3 feet because you plan to lean it against your shed. So you would have your shed as your vertical length, whether that's on the right or on the left. Now it's asking how high up the wall of the shed is the top of the panel. So either way, we want to find the vertical length. We do not know the horizontal length, but we do know the diagonal. We do also know a degree. So we can't use the Pythagorean theorem because the Pythagorean theorem would require us to know two sides of the triangle, but we do know one side and we do know an angle. And we're trying to find another side. So we're going to use a trig function. We want to think about those three basic trig functions: sine, cosine, and tangent. And hopefully you have memorized the SO, CA, TOA. So we want to label these 3 feet and the vertical height using O, A, and H, or opposite, hypotenuse, or adjacent, in relationship to the actual angle. So the angle, if I'm looking at this triangle over on the right-hand side of the screen, the 3 is going to be the hypotenuse because it's across from the 90-degree angle. It's also the longest side. And then the X, or the vertical height, is opposite. So we want to see that we've got opposite and we've got hypotenuse. So we've got O and H. The only trig function that involves both O and H is sine. So I'm going to put the sine. Remember, it's the sine of the angle is equal to the opposite over the hypotenuse. Then fill those in with the knowns from this particular situation. So we've got the sine. We do know the angle is 31.8 degrees, and that's equal to the opposite, or my X, over the hypotenuse, which is 3. Solving this for X, all we need to do is multiply both sides by 3. And then throw this into our calculator, making sure that we've got it in degree form. Using my basic calculator that I've got on my computer, I do need to enter in my 31.8 degrees first, take the sine of that, and then multiply it by 3, hit equals, and we can then see that X, or that vertical length, is going to be approximately 1.58 feet. Now, in the real world, although this is acceptable on the test based on they wanted us to give the answer to the nearest hundredth of a foot, so they're okay with decimals, this typically wouldn't be an appropriate answer in the real world. You would want to know how many feet and inches, which you might even say it's 1.5 feet, depending on how exact you need it to be. If you need it to be a little more exact, what you can do is say that this is 1 foot and then 0.058 of a foot. But let's convert that feet into inches. We learned how to do this in Module 1 using a conversion factor. We know that 1 foot is actually 12 inches. So back to our calculator, if you still have that answer exactly in your calculator, what you can do is just subtract off the 1 foot. Now we have the partial foot, multiply that by 12, and this will change us to inches. And so I get 6.97 inches which is probably close enough. Again, we aren't going to the moon or anything, so we might just say, hey, let's go up 1 foot and 7 inches. That's a more practical answer.